Hello. Do you recall the last time you climbed into a hot vehicle in the middle of summer? It was miserable, wasn't it? But then you started the vehicle and felt the cool blast of AC from the vents. How did the hot air become cold, and what components enabled it to happen? The process you experienced is refrigeration. It is one that we deal with in various facets of our everyday lives. The process is used to manufacture and store thousands of products we find in the stores. It is of course also used in our homes in the form of refrigerators, freezers, and air conditioning. My name is Ben Lumix, and I am a certified industrial refrigeration operator with 8 years of experience operating, maintaining, and managing refrigeration systems in various yogurt manufacturing facilities. Over the next few minutes, we will touch briefly on the four main components of the refrigeration system and how they operate together to cool us on those hot summer days. The first component is the compressor. In the compressor, refrigerant is compressed to a high pressure and a high temperature. During this process, mechanical heat is absorbed into the refrigerant. An example of this would be squeezing an ice cube with your hand. Squeezing the ice cube tightly packs the molecules, causing friction and heat. The ice cube melts much faster in your hand than if you were to set it on the table and allow it to melt on its own. The next component in the system is the condenser. In the condenser, the refrigerant that is a hot gas is condensed into a hot liquid, a hot high pressure liquid at that. The heat is rejected in this process. It is rejected with air from a fan, water from water nozzles, a hose, or a combo of the two. An example of this would be water vapor in the clouds. The vapor condenses after it has risen into the atmosphere. Another example would be the top of this humidifier. In the humidifier, the excess water vapor that is not being expelled out the top collects at the top of the container and rains back down into the basin. The next component in the cycle is the thermoexpansion valve. The purpose of the thermoexpansion valve is to control the flow of refrigerant to the evaporator. During this process, heat is rejected. It's rejected due to the change in state of the refrigerant from a liquid to a wet vapor. The refrigerant is at a low pressure now and is very cold. Once it crosses the valve, inside the valve, what is happening is you have liquid on one side, a small port in the valve, and on the other side of the valve, the refrigerant turns into a fine mist or vapor. It's still feeding the evaporator coil with liquid, but it is now a low pressure, low temperature, high velocity vapor. An example of this would be the humidifier blowing water vapor out the top. The pump inside the humidifier is creating pressure, but after it is expelled out of the humidifier, it is just a gentle mist, as you can see. After the thermoexpansion valve, the vapor now enters the evaporator coil. The purpose of the coil is to cool your food in the refrigerator or freezer, your car, or your house. Heat is absorbed during this process. Hot air travels across the coil and cools rapidly. Refrigerant boils as well and evaporates, sending dry vapor back to the compressor. An example of this would be water vapor evaporating out of the humidifier. If you picture the humidifier, inside of there, the water is boiling. As it boils, it is also cooled by going back through the basin, and then it is blown out of the top. If you imagine that mist as the vapor coming off the evaporator, that gets sucked back to the compressor. Refrigeration is, in essence, the transfer of heat across two mediums. It might be getting rejected at the condenser, or absorbed at the compressor, then rejected at the thermal expansion valve before it is again picked up at the evaporator. Without one of these components, the refrigeration process cannot succeed. And without one of these components, you would be very uncomfortable on a hot summer day. Thank you.